Okay, so the very last example I'm going to do is of x squared sine x dx. Now these sorts of combinations are they're a little bit interesting, and they're a good demonstration of how we can use integration by parts. So if we look at the two types of functions here, we have x squared and we have sine x. Now one of the things that we know about the derivatives and integrals of sine x and cosine x is that they keep on cycling through. So the derivative of sine x is cosine x, the derivative of that is negative sine x, the derivative of that is negative cosine x, etc. And it keeps on cycling through like that. And we know that for polynomials like this, that it sort of gets simpler as you keep differentiating. So x cubed gives you 3x squared, which gives you 6x, which gives you 6, which gives you 0, again like that. So basically what we want to do in order to make this a simpler derivative is we want to keep on differentiating x squared while this side becomes no more complicated. I'll show you sort of how this works. So I'm going to call this my u and this my dv dx. And so then I have du dx equals 2x, and I have my v equals the integral of sine x, which is negative cosine, better write it, integral of sine x dx equals negative cosine of x plus c. So when I put these together, I get that x squared sine x dx is equal to u times v, so x squared times, so it becomes negative cosine x minus the integral of, and now putting together v times du gives me negative 2x cosine x dx. Now I have to deal now with this integral here, so neatening it up a little bit, I get negative x squared cosine x plus 2x cosine x dx. I might even take the 2 outside. And so I have to find this integral now, and we might say, well, I haven't really changed anything, I haven't made it easier, but actually I have, because now I've just got an x and I've got an x squared. So now what I do is I actually apply integration by parts again. So now I'm going to say, again, call this a new u, and call this dv dx here. And so that gives me du dx of this part is going to be equal to 1, so that's nice. And then v is going to be the integral of cosine x dx, which is equal to sine x. And so now putting this all together, I get the integral of x squared sine x dx equals negative x squared cosine x plus 2 times, and now I'm going to have, dealing with this integral here, it's going to be the u times v, so that's sine x there, times x sine x, minus the integral of du dx times v, which gives me just the integral of sine x dx. And this now I have no problem dealing with. So I get negative x squared cosine x plus 2x sine x minus integral of sine x is negative cos x, so I get plus cosine x here, plus my constant of integration c. And I could do some simplification, etc. there as well. I think that fits in. So it's a little bit more complicated. Again, as an exercise, you might want to try finding the derivative of this and verifying that we do get up to here, because we should get a little bit of cancellation, etc. But yeah, as we see, so we can apply multiple times this derivative. And so if this was any polynomial, x to the 5, etc., we could continually, iteratively apply each step. each time.